Ever find yourself wishing you could, like, download knowledge straight into your brain?
Wouldn't that be something?
Right. Well, today we're diving into something that's maybe like the next best thing. Can you actually train your brain to be smarter? Like, can you actually boost that, mental agility, that quick thinking, problem solving power we call fluid intelligence? You sent over some research on this, and I gotta say, I'm super intrigued.
Well, yeah, I mean, it's a question that's really, captivated researchers for years now.
Mm.
Because, it really challenges this whole idea, this long-held belief we've had that we're, like, stuck with the intelligence we're born with,
Yeah. Like, it's just we're wired a certain way, and that's it. End of story. But what if that's not the whole story?
Exactly. What if intelligence is less like a light switch and clear
More like what?
more like a muscle,
Mm.
something you can strengthen with the right kind of workout.
Okay. I like where this is going. So we're not just talking about like memorizing a bunch of facts here.
No, not at all. Crystallized intelligence, like all those facts and figures. That's important, of course. But fluid intelligence, that's your brain's ability to adapt, to solve problems it's never even seen before,
Wow.
to learn new things really quickly. That's what's really interesting here.
So think less trivia night at the bar, more like, figuring out a new subway system in a foreign country on the fly.
Perfect example, yeah.
Hmm.
And the research is really starting to suggest that that fluid intelligence might be way more trainable than we once thought.
Okay, now that is exciting. But how do you even begin to train something as complex as intelligence?
Well, researchers like Susanne Jaeggi and Martin Bushkuhl, they've really zeroed in on this thing called working memory as the potential key here. And it's not just about remembering information. It's about actively using it, manipulating it in your mind,
So, like, if I ask you to remember a string of numbers, but then I also ask you to, like, add them together in your head, that's your working memory working on all cylinders.
Exactly. And it turns out that working memory is really, really closely tied to fluid intelligence. It's like the mental workspace where we process information and make those connections.
Okay, that makes sense. So if you can improve your working memory, could that then lead to a boost in your overall fluid intelligence? Is that kind of what researchers are finding?
That is the million-dollar question. And Jaeggi and Buchkuhl have done some really, really intriguing work using this deceptively simple, it's like a game-like task called the NBAC to try and answer it.
The end back. All right, so lay it on me. What is this game all about? How does it work? Okay, end back. Give it to me. What kind of game are we even talking about here?
Okay, so picture this. You're looking at a grid on a screen.
Yeah.
And a square lights up.
Okay.
And then another square, then another. Your job is to remember if that current square is in the same spot as it was, say, 2 squares ago. So that'd be like a 2-back task.
So if it was 3 squares ago, that'd be 3 back. And it just gets tougher from there.
You got it. Exactly.
Right.
Yeah. And so your working memory is it's getting put through its paces, right?
Yeah.
Because you're constantly updating what you need to remember, juggling all those locations in your mind.
Yeah, it sounds deceptively simple when you explain it like that, but I have a feeling it gets really, really tricky really quickly.
Oh, absolutely. Especially, they start introducing things like, the dual end-back task, where you're not just tracking the square's location, but you're also trying to remember a sequence of letters, like you're hearing at the same time.
Whoa. So you're juggling locations and sounds.
Oh, yeah.
That's like next level brain training. So did this NBAC game actually lead to any noticeable changes in people's fluid intelligence?
Okay, so this is where things get really interesting. The people play this NBAC game like regularly, and after a few weeks, they tested them using something called Raven's progressive matrices, which is it's like the gold standard for measuring fluid intelligence.
Okay, Raven's matrices. Yeah, that rings a bell. Remind us what those are all about.
So basically, you're presented with a series of patterns. Mm-hmm. So it's like they're like visual puzzles with a missing piece, and to find the missing piece, you have to figure out like the underlying rule of the pattern.
So it's not just like remembering what you've seen before. You have to actually like use logic and reasoning to solve something totally new.
Exactly. Yeah, it really tests your ability to see those patterns, to think abstractly, and to solve problems like on the fly.
Right.
All those hallmarks of fluid intelligence. And what Jaeggi and Bushkuhl found was that the people who trained with this NBAC game were significantly better at solving these matrix puzzles after just a few weeks of of training.
No way, really? So playing this like seemingly simple game actually translated into measurable improvements in their ability to solve like complex problems.
Yeah, and it wasn't just like a small improvement either.
Yeah.
They were solving, like on average, like 4 or more matrix questions correctly after training than they were before. And that kind of jump, that really suggests that the NBAC training wasn't just making them better at the game itself, but it was actually like having this broader impact on their cognitive abilities.
Okay. Okay, now I'm starting to see why you're so excited about this research.
Well,
But this is just one study, right? Like what's the bigger picture look like here? Are there other researchers who are finding, similar results?
yeah, no, you're right to ask about the broader context here. Because Jaeggi and Bushkuhl's work it's really compelling, and it's sparked a ton of new research in the field. And while some of the findings are mixed, there are other researchers who are exploring different brain training methods, and they're showing some really promising results as well.
Like what? Give me some examples. What kind of methods?
Okay, so for instance, there's Torkel Klingberg. He's a researcher who's done some really fascinating work with kids who have ADHD. And as you know, that often makes it really hard to focus, to control impulses.
Yeah.
Right. And so he uses these computer-based exercises that are like specifically designed to target and strengthen working memory.
So kind of like a digital boot camp for your working memory.
So what did he find?
Well, his results they've been pretty remarkable actually. So after just like 5 weeks of this targeted working memory training, not only did the kids, show improvements in their working memory capacity, but they also did significantly better on tests of fluid intelligence. Like you guessed it, Raven's progressive matrices.
Wow. So that seems to support the idea that improving your working memory can have these ripple effects, right? That it can actually boost other cognitive skills as well.
Right. It's like you're giving your brain this mental workout, right? And the benefits, they extend beyond just those specific exercises that you're doing.
Yeah. And it's not just Klingberg either, right? There's Jason Sheen at Temple University, and he's found that working memory using slightly different tasks can actually lead to some really practical improvements.
Practical how? Like how so?
In one study, he was working with college students, and he found that the students who went through this working memory training actually showed improvements in their reading comprehension.
That's what I'm talking about. Imagine the potential impact if we could actually help people become better readers, better learners, just by doing these targeted brain exercises.
Absolutely. And then there's Sylvia Bungie at UC Berkeley. She's taking kind of a broader approach. So, not just focusing on working memory, but really incorporating a wider range of cognitive skills into her training programs.
Like what kind of things? Fill me in.
So her programs include things like tasks that really challenge your perceptual speed, your reasoning abilities, your ability to think flexibly and to kind of to switch between tasks.
Okay.
And she's found some really encouraging results, especially with kids from disadvantaged backgrounds who often face more challenges, I think, in traditional educational settings.
So she's finding that brain training could be like a way to kind of like level the playing field, to give these kids a leg up.
That's the idea, yeah. Mm-hmm. Some of her studies have shown that kids who participate in her programs can actually see, significant gains on standardized tests like nonverbal IQ tests.
Yeah.
And sometimes increasing their scores by 10 to 20 points.
That's incredible.
Yeah.
Okay. So, we've got Jaeggi and Bushkuhl's, NBAC research. We've got Klingberg's work with kids in ADHD. We've got Janie's findings on reading comprehension and Bungie's, more comprehensive approach. It's really starting to feel like there's like a real there, when it comes to brain training. But I'd be remiss if I didn't ask, like, what about the other side of the coin here? Are there researchers who are, I don't know, shall we say, less convinced about all of this? So we've heard from the believers, the researchers who are seeing some really, really promising results with this whole brain training thing. But what about the skeptics, right? there's got to be another side to this story.
Oh, absolutely. Yeah, and it's really important to hear those voices too,
Yeah.
because not everyone's convinced that brain training is like this cognitive revolution it's sometimes made out to be. One of the most vocal critics is Randall Engel.
Oh.
He's a highly respected intelligence researcher.
Okay, so Randall Engel, what's his take on all this?
So Engel, he argues that fluid intelligence is primarily driven by, our biology, like our genes, the physical structure of our brains.
Okay.
Right. And because of that, he believes that it's largely resistant to change. He doesn't disagree that we can get better at specific tasks with practice, right?
Yeah.
Like if you do a lot of Sudoku, you'll get really good at Sudoku. But he's not convinced that this, that this translates into like a broader increase in your underlying cognitive abilities.
So it's like saying just because I'm like a whiz at crossword puzzles doesn't mean I'm suddenly going to be like a world-class chess player.
Exactly.
Yeah.
Yeah, he's made the comparison that trying to boost your IQ by,
Yeah.
by training on brain games is like trying to make yourself taller by playing basketball.
Right.
You might become a better basketball player, but
Yeah.
you're not fundamentally changing your height.
Right. So he's saying it's more about getting better at the specific thing that you're practicing, not necessarily like rewiring your brain to be smarter overall.
Yeah. That's the gist of his argument. Yeah. And he's even compared all the buzz around brain training to the cold fusion craze.
Right.
Back in the day, it's a lot of hype, but not a lot of substance.
Wow. That's a pretty harsh comparison. Okay, so we've got Engel over here who's let's just say cautiously pessimistic about the whole brain training thing. Any other big names in the skeptic camp we should know about?
Yeah, so another study that's worth mentioning was led by Adrian Owen. He's a neuroscientist who teamed up with the BBC for this massive online experiment. They had over 11,000 people participate in all these different brain training exercises over 6 weeks.
Wow, 11,000 people. That's huge. So what they find with a study that big?
Well, so the participants they did show improvements, but here's the catch.
Okay.
They only improved on the specific tasks that they trained on. So like if they practiced a memory game, they got better at that memory game. Mm-hmm. But when they were tested on broader measures of fluid intelligence, like those Ravens matrices we were talking about earlier, there was no significant change.
Okay, so that seems like a pretty big point for the skeptics then. Like if these brain training exercises aren't actually translating into improvements in other areas, then what's the point, right?
That's the $1 million question, right? And I think it's really important to acknowledge that the research is still ongoing.
Of
right?
course, yeah.
There are definitely some promising findings out there, but there's also a need for more, for more rigorous long-term studies to really understand, how these brain training interventions work, who they work for and how long the effects actually last.
Yeah. It sounds like the jury's still kind of out on this one. So where do you land on this whole thing? I mean, like where do you fall on the spectrum between like brain training is the future and it's all just hype?
I personally, I find the research incredibly exciting. Even with all the debate, even with the questions that still need to be answered, I think it speaks to the incredible adaptability of the human brain. We might not be able to like turn ourselves into into geniuses overnight, but the idea that we can actively improve our cognitive abilities, our mental agility. I mean, that's pretty powerful stuff.
It's definitely a more like optimistic way to look at things than just assuming we're stuck with the brain that we're born with, right?
Exactly. And think about it this way: even if the effects of brain training are are really specific to the task that you're practicing,
right?
Isn't there still like value in that? Whether it's sharpening your memory or improving your focus or becoming like a better problem solver in a particular area. I mean, those are all like incredibly valuable skills.
Absolutely. And who knows, right? Maybe as the research continues, we'll discover even more effective ways to train our brains and really, really unlock even greater cognitive potential. It's an exciting field to watch. That's for sure. But hey, you know what I'm thinking.
What's that?
Even with all this talk about, NBAC games and these fancy brain training programs, don't you think there's like something to be said for just challenging our brains in our everyday lives,
Oh, yeah.
Like learning a new language or picking up a musical instrument or even just doing a crossword puzzle every day.
You're absolutely right about it. It's all about keeping our brains,
Mm.
engaged,
Yeah.
challenged,
Yeah.
active. Just like our bodies, our brains, they thrive on novelty and variety. So, yeah, I mean, while those targeted brain training exercises,
Yeah.
might have their place. I think the most important thing is to really like cultivate a lifestyle of lifelong learning.
Well said. Well said. So for you listeners out there, the next time you find yourself, reaching for your phone to scroll through social media, maybe consider challenging yourself with a quick brain teaser instead. You never know; those mental workouts might just be the key to unlocking a sharper, more adaptable you. And on that note, we'll leave you with this final thought. If you could design your own cognitive workout routine, what would it look like?